Yeah, so hello everyone, hello YouTube. Banana Boy explains DSA here, and today I'll be explaining you all how to how to detect a cycle in a linked list and uh, mainly on how to detect where the cycle starts in a linked list, of course. So, assuming that we have a linked list here, let me just grab my pen. Assuming that we have a linked list here, this is the head, and let me just draw with my mouse. Assuming that this is our linked list, and let me just la 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 la. Let's say that this is our linked list and this is the part where it loops, and we don't know how many elements are there in this loop. Okay, there can be 100, there can be 200, or there can be just one. We don't know how many elements are there, okay, how many nodes are there. So what we are going to do is the most optimal method of detecting a cycle. So we will first try to detect if there is a cycle in a graph or not. So we will use the hare and tortoise method. This is our hare, which this is our hare and this is our tortoise. So these are our two pointers that is going to initially point to the head of our linked list. So what are their properties? So the tortoise with each iteration, the tortoise let me just select the tortoise. The tortoise only jumps one node at a time with each iteration. My mouse isn't working. Yeah, so with each iteration, our tortoise is going to jump only one node at a time. Okay, but the same is not for our hare. Why the fuck are you doing that? So yes. Oh, what the? My mouse is not very acting really good today. Yeah. So for our hare, with each iteration, our hare is going to jump two nodes at a time. So if it is, oh my goodness, what the? Yeah. So if it is at here, then with on the next iteration it will be here, on the next it will be here, and at the next it will be here. So with that we can detect if there is a cycle in our graph or not. So how do we do that? We will going to have to run a while loop. We will going to have to run a loop where which runs until our hare and the tortoise pointer meet until. So what that logic means is that with each iteration our tortoise is going to jump one node at a time and our hare will jump two nodes at a time, and then in the next iteration our hare tortoise will jump two nodes, and similarly our hare will jump two nodes. Sorry if I said that ulta. And so in the next iteration it will jump one node and this will jump two nodes. So I guess this is, I don't know. Yeah, so um yeah, whatever. Why is this like this? Yeah, so okay, the hair should be here. The hair should be here. Yeah, yeah, so as we can see our hair is currently here, and after a certain amount of time, the both our hare and tortoise have entered the loop currently. So after n number of iterations, or maybe any amount of iteration, our hare and tortoise will certainly at any given iteration meet, and this is how one can conclude that, let's say it is this node. So with that we can just simply conclude that our cycle, our linked list contains a cycle, and and if not, if our hair encounters a null pointer, then that means our linked list was simply a linear linked list. So that would mean that there is no cycle in our graph. So how do we actually know that? How do we actually know that our linked list? How do we actually know where our loop starts? Like this is the point visually where our loop starts. But how do we know that exactly? We do that by simply whenever we hit the case where our tortoise and hare first meets inside the loop, we will have to bring in another loop. We'll have to break that loop, and then we will run another loop where our tortoise is reinitialized to the head, where our tortoise is reinitialized to the head, and our hair changes its property, and now both of our pointer will, with each iteration inside the second while loop, will only jump one node at a time. So by that logic, in the new loop, the first iteration will do this, and the second iteration will do this, and then the second iteration will do this, and then this, and eventually they will meet. And where will they meet? It is exactly at the point where our loop starts. And no, this is not some magical test case or something. This this technique, or you may call it an algorithm, it always works. Why? Because there is a really mathematical and logical proof that is going on behind this whole scenario. And wherever they meet in the second while loop, you can simply return the position of our hare or our tortoise, that this is the specific node where our loop starts. Yeah, so on to our proof, that why does this happen. So we will have to reinitialize our, so on to our proof. This was the algorithm. Like I will write it out. Run a where the tortoise jumps one node at a time, and the hare jumps two nodes at a time, and whenever they meet, and if they meet, then there exists a loop, and if they don't, which means our hare encounters a null pointer, then there is not any. So, ah, yeah. So after this, if we want to find out where our loop starts, so for that we will do run another initialize our tortoise position to the head again, but leave the hair as it is. I mean, where they first met. Yeah. Uh, run another loop, and I don't know what the I can't find any word for it, but and with each iteration with each iteration our hare and tortoise will jump one node. Tortoise both will jump one node. Both will jump one node. No, jump one node, and wherever they meet, they will definitely, because there is a loop, and if they do not, then maybe your code is wrong or something. And whenever they meet, that is the node where our loop starts. Hooray! Yeah, so this is how the algorithm works, and now we will see its proof. So on to our proof. Yeah, you can maybe screenshot it or something. Yeah, so on to our proof. I will simply delete this. Yeah, so on to our proof. Let's run this again. And like there is another hidden property of this, two pointer approach, the hare and tortoise approach, that that if this is our linked list, okay, if this is our linked list, then we all know that hare is running twice as the speed of our tortoise. Then if our hare completes, if our hare completes the loop, then if reaches the end of our linked list, then if our hare reaches the end of our linked list, then our tortoise we would only have had covered half the distance of our linked list. Then that means wherever the tortoise stands, whenever the hare completes completes iterating over the entire linked list, that is where our midpoint, or that is where the midpoint of our linked list is. Yeah, so yeah, this is the property that this technique holds, secret property, secret property. Yeah, so um let's say our hair is here. Nice terminology. Yeah, let's ignore the hair for now, and let's say our tortoise is here. Okay, so we are simply assuming that this is a node of suspicion. So if our tortoise is here, and this is our length d, and this is our length d, v, yeah, and this is our length v, d, then our hair logically should be here, and this will be d, of course. Yeah, because the hare would have traveled twice as much as distance our tortoise have had until now. Yeah, so this is basically yeah, yeah, I mean, I don't need to explain that anymore. So we still don't know how much distance is left inside our remaining loop. Yeah, so let's just name it x, that this is how much distance is still left inside a loop. And to close that distance, to meet our tortoise, our hare with, okay, yeah, with each iteration, our hare, so like that simply means that the distance between our hare and tortoise is now x. Yeah, am I right? Yeah. So the distance between our hare and tortoise is simply x, and the distance between our tortoise and hare is d. I mean, yeah, this is a circle, so we can assume both of that, but we will assume that the distance between our hare and tortoise is x because they can only travel in one direction. So in the next iteration, our hare will close the distance. So our hare will close the distance by 2. Meanwhile, our tortoise is not standing there statically. They are also traveling, so they must have moved by 1. Okay, because a tortoise is always leaping forward 2 times, while the tortoise is always moving forward 1 time. So that simply means with each iteration, The distance between our hare and tortoise is reducing by a factor of 1, by 1 unit. So after x times, x iteration, call it x times or x iterations, the distance between our hare and tortoise will be 0. That means our hare is now on top of our tortoise. That sounds really sexual. Yeah. Is Yeah, so that simply means that our hare has met our tortoise. So what does that mean? That x iterations have happened. How much in x iterations, how much distance our tortoise have walked till now? It's x because they are traveling one node with each iteration. Then how much distance have our hare walked till now? That is 2x. So which that simply means that if they are starting here, so that okay, wait a minute. System hang. Yeah, so if if our hair is starting from here, so that means it will travel 2 2x before meeting our tortoise. Yeah, so uh, out of our 2x, the first x is here and the second x will be here, will be this much. Let's just assume the x that x is bigger than our d. Okay, so this is our second x, and this is where our hare and tortoise first meet. Hare and tortoise first meet. Yeah, so let's just assume that this is not here, that this is not here, this is not here, and this is also not here, and also this. So our new distance system becomes this, that this is this is where our hare and tortoise meet. You know, from the starting of this suspicious node, they have met x distance away. Then the whole perimeter of this loop is, let's say, L. Then it consists of, we both know, we all know, x plus d. I hope I am being clear right now. So if this is x, then how much is this? How much is this distance? It's d, because our perimeter of a circle is d plus x. It is d plus x. So from this exact point, we reinitialize our tortoise to our head. This is where our second loops comes in play, and this is where our tortoise is right now. And then our tortoise will, with each step, will with each iteration travel d distance, and our hare will also travel d distance, and they eventually logically travel the same distance and then meet at this position, which is, I mean, finally our the node where the loop begins. Yeah, so this is the really nice proof of how this algorithm works, and all the mathematical stuff behind it, of how it finds, of how it is derived. So this is how. Yeah, thank you so much for watching. Bye bye.